Huh? Hey guys, it's Vignesh from BreVITy. Today we will be learning about two-pointer algorithms. Two pointers is a powerful technique that can solve a lot of problems in constant space and linear time. It does so by utilizing two pointers or two variables. Two pointers is a spectrum of different techniques. It is an umbrella term for algorithms that use two pointers primarily. Some of the subcategories are fast and slow pointers, cycle detection, which is an application of fast and slow pointers, left and right boundary based two pointers, and sliding window. Sliding window is a vast topic in itself, so we'll be covering that in the future. We'll explore everything else in detail in the forthcoming weeks. Fast and slow is a subcategory of two pointers where the said two pointers move at two different speeds. For the visual representation, we'll be staying true to the classic example and use the hare to represent the fast pointer and the tortoise to represent the slow pointer. Let's see how we can find the middle of a linked list without knowing the actual size or length of the linked list or array. Our comrade Shankar had explained this in great detail earlier in the series, so we'll be doing just the visualization part of that. As you can see, the hare moves two steps at a time, while the tortoise moves only one step at a time. So when the hare has reached the end of the array, it has traveled the entire array, while since the tortoise is moving at half the speed of the hare, it has only reached half of the distance, that is the middle of the array or linked list. Hence, we can find the middle point or the center of a linked list or array without knowing the actual length or number of elements in a linked list or array. Now that we've set the stage for what fast and slow pointers are, we can now learn a very powerful application of this algorithm called Floyd cycle detection algorithm. Here's the crux of this algorithm. Two different objects moving at two different speeds on the same path will only meet again if their path is a circle. That is, if the two objects are moving on a straight line, there is no possibility of them ever meeting again. But if their path is a cycle or circle, definitely they'll meet again at some or the other point on the circle. Now, you might ask, how does that translate to computer science terms? Assume there is a linked list where a node contains an X pointer which points to another node and so on. Now, if the tortoise and hare were considered as two different pointers and they would be moving at two different speeds, then it is very much clear that they'll never meet again. But if the linked list had a cycle at some point, then observe this. That's it, they'll meet again because there is a cycle. This is how we identify very quickly, without any extra memory, that there is a cycle in this linked list. Let's bridge the gap between the analogy and code. The hare in the analogy represents a variable named fast. Tortoise represents slow, and each step means each iteration of the loop. And one step at a time means that the slow will move to the slow's next position. And two steps at a time means that the fast will go to next position, and the point where they meet can be of two different types. One, if there is no cycle in the linked list, then the hare would have reached the end of the list. Or if there is a cycle, then fast and slow will point to the same node at the same time. That's how we know that there is a cycle. To write the code for this, we'll be adopting this four-step process. First, we'll implement the logic, then add conditions for checking the edge cases, then debug if there is any errors, and optimize. It is perfectly okay to cry at any point in this process, and if it does not work, reiterate the same process all over again with a little bit more tears. Now that you intuitively understand what Floyd cycle detection is, feel free to choose one of the programming videos in C++, Java, or Python. No pressure at all. I'll wait.